Hi, welcome to the next session in doing data analysis in R. In the last session, we began working with R. We did some data visualization in the ggplot2 package, and in this session, we will be doing some data transformation. We'll be coming back to data visualization in a future session. Specifically with data transformation, by the end of this lesson, you should be able to select, filter, arrange, and mutate data sets. We'll be using the dplyr package written by Hadley Wickham to do these data transformations. The dplyr package is part of the tidyverse package. So let's start by doing some coding. You can open up your session folder, click on the rstudio.rproj file, and that will open up RStudio in the working directory of that file folder we're just in. And it opens up, typically, if you haven't already opened anything up, or opened that session up, it will open up with just the command prompt on the left. And again, remember, you can type stuff into the console, but typically we operate with scripts. So we can go ahead and open up the script, data transform, select, filter, arrange, .r file. I'm going to scroll down to here, this first section, and it's asking you to install the example data from GitHub. Go ahead and run that, and then when you're done, you should be able to, on your own, carry out these commands. Please pause the video and try that now on your own. Okay, to load the example data package into the session, use the library command. To view it, like a spreadsheet, wrap it with capital V, view. And we want to view just specifically the Wegmans data set from the example data package. And it will open up this window here. The next question asks, if you want to learn more about something, a built-in data set or a function, use the question mark command in front of that particular function or data set. And here it tells us all about this data set. And we can find out that, hey, this is a fake grocery data set for the Wegmans store. And then we loaded the data, or tidyverse package with a library command. Now we're going to move on to piping. And if you would like, this video here is Hadley explaining a bit more about piping, but I'm just going to explain it here rather quickly. Now typically, coders can write code something like this. This is called nested coding, and you work from the inside and you work outward, and you keep wrapping and nesting up code. And that's great for computers. Computers like this. So we can take rnorm20, and I highlighted just that, Control Enter, or Command Enter, I believe, if you're on a Mac, and it sampled 20 normal values from the normal distribution, right? And then we can wrap that with a mean, and get a mean for that, right? And then we can round that up, or round that with a round function, right? Okay? Now each time, when you're grabbing a random normal sample, the values can change. So what I'm doing here is setting the seed, and that means that each time it will always grab the same 20 random values. So if we run that whole code, we get it rounded to negative 0.06, right? And this is great for computers. Computers can read that, they understand it. Bad for humans. This isn't typically how we read. Typically in English, we don't start in the center of the page and read outward. We start from top, and we read to the bottom, and we read from left to right. And piping allows us to do that. And you can see what a pipe is right here. It's a percent greater than percent sign. And what this does is it takes the value from the first line and pipes it to the second. And it's read as then. So you would read it like this. First, take a random sample, 20 values from the normal distribution. Then, pass it on to mean. Take the mean of that. Then take that mean and pass it on to round and round it to 2 digits. And the pipe, what it does is it passes itself to the first argument of the next function or next command, right? So you don't even have to write anything inside of mean here. It just interprets it as passing this value to the first argument of mean, okay? And we're going to go ahead and run this, and we should get the same values we already got before. I have not yet loaded the tidyverse package. So I went ahead and loaded it, and I'm not sure if I loaded example data. There we did. Go. And we go ahead and run that, and we got the same value as we did before. The difference between nested coding and piped coding is humans can much better read this piped code, and that's what we'll be using throughout these lessons. Okay, let's head back to the slides for a little bit. Now, Hadley Wickham makes the claim that I have 5 verbs and then one other command called group by. And if you learn these 5 verbs plus group by, you can do like 90% of all your data manipulation. And I would tend to agree. In my work, I can do a lot of my data manipulation needs with those 5 verbs and group by. And here are the 5 verbs. Select is the first one. It says grab these columns. Filter is the next one. It says grab these rows that match a certain condition. Next is arrange, and it just sorts the rows on a particular column or columns. Next is mutate, and that creates new columns or new variables, same thing. And last is summarize, and what this does is take variables or columns and reduces them down to a single value. And the last thing is a group by, and this is not a verb, but what it does is it acts on mutate and summarize. Well, it can actually act with any of the verbs, but it's really quite useful with mutate and in particular summarize. And what it does is split the data set up into pieces based on a grouping variable, splits it up into pieces, applies some sort of function on it, and combines the results back together. And we'll learn more about that. I want to talk a little bit more about mutate and summarize. They use functions. Now, these things, mutate and summarize, they tell you how to apply a function, right? So what's a function? Well, it takes rule or inputs, applies a rule to it, and then returns an output. So there's a function machine. And there are two basic types, generally. There are window functions and summary functions. And a window function will take n values and return n values back. A summary function will take n values and return 1 back. And typically a window function is used inside of mutate, and typically a summary function is used in summarize. Some examples of window functions are square roots, squares, plus, minus, add, subtract, divide, and so on and so forth. If you give it 5 values, it'll return 5 values back. Some examples of summary functions are mean, median, mode, minimum, max, those sorts of things. If you return 5 values, it will return 1 value back. Okay? The 4 verbs that we will mostly focus on today are select, filter, arrange, and mutate. Next session we'll be working more with mutate, summarize, and group by. So let's get back to coding. So selecting. Here I have some code for you. We took Wegmans, we pipe it to the next line, and we're going to select by name these 3 columns. So let's go ahead and run that. You can see right there that those 3 columns were indeed selected. And you can pass as many column names as you want. Real nice shortcut for, let's say that you have, let's go type in the Wegmans data set. Let's say you wanted to grab from wholesale clear up to popularity. It's kind of a pain to type out all these columns, so what you can do is use the colon operator and say grab from wholesale all the way up to popularity. So it's a nice shortcut. We can see it does indeed return what we'd expect. You can also use negation to drop columns. Right there we just dropped department. And we could drop more than one by saying minus item. And indeed dropped item and department. That's kind of a pain in the tuchus to keep putting a minus sign in front of the columns we want to drop. So what you can do is actually wrap up those columns into a vector using the C function and put the negative right in front. So here we're going to drop wholesale, we're going to drop old price. You can even drop, using the colon operator, multiple columns. And that's what we went ahead and did there. So select is really quite powerful. I'd encourage you to pause the video and try a few of these on your own now. Okay, we're on to the next verb. First we did select, we're now on to filter, and this grabs rows based on a condition. And conditions typically use comparison operators, and here they are for R. Most of these are pretty familiar to most folks. Greater than, or equal. One that might not be here is the not equal command. And here's another one. You might think to say, oh, I want to find something that's equal to, you just use a single equal sign. Not in R, you need a double equal sign. So for instance, in SQL, you can use a single equal sign. In R, you need a double equal sign. And one more operator that's really quite nice, comparison operator, is the % in %. And what this allows you to do is to say, find values in a vector. And we'll talk more about that, and it'll make more sense. One other powerful thing to add to this filtering are booleans, where you can join multiple conditions together using ands or ors, and the or is a pipe. And you can see that the and is an ampersand. So let's go ahead and practice a few of these, or do a few of these. We're going to grab from the Wegmans data set, filter, grab just the rows where new price equals $3.09. Go ahead and run that, and we can see there are 2 items, lettuce and water, that are equal to $3.09. Next it asks, what items are more than $3.09? So that's just the same exact code that we wrote above, but with a greater than sign. And if you're not catching on, you can see that the first argument to this condition is we passed in the variable name, or the column name, new price, and we want any time that it's greater than $3.09. The next question asks, what items are at least? So that's a greater than or equal to. Same exact code as above, just with a slightly different condition, comparison. And we can see that we now have 11. So this is actually a combination of the previous 2 code chunks, where we're doing greater than or equal to. Next question asks, hey, what items are above $3.50 or below $2? So this or gives away that it's a Boolean. So we want to do 2 conditions. There's the first condition, there's the second condition. And it wants to know the price, so we take new price, where it's less than $2 or above $3.50. So we go ahead and run that. And we can see that there are 4 items, skim milk, pineapple, rye, and pork. And we can see their prices here. The majority of them are actually above $3.50. Only one is below $2. Next, we have a question or task that asks us to find items that are between $2.75 and $3. So we know that this is a Boolean and. Okay, and the first condition is it has to be greater than or equal to $2.75, and the second says that it has to be less than or equal to $3. So we go ahead and run that, and we can see that there are 5 items that match that: beer, roast beef, corn, carrots, and steak. And we can see, hey, yeah, that value there, $2.99, that's above $2.75 or equal to $2.75, and it's below or equal to $3. In fact, all of the items here have new prices between those. There's a nice little shortcut in dplyr for doing a between like this, and it's nicely named the between function, and it's a shortcut for this code right here. And all we do is we pass in the column name, and we say it should be between the lower value and the upper value, and we should get the same items returned, which we do. So there's a nice shortcut so we don't have to keep typing over and over again new price. Next question asks, what items are 5 stars popular and cost less than $3.50? So here we're talking about popularity, that's one column, and then we're talking about cost, that's another column. So you can filter on multiple columns. So the first condition, so this is a Boolean, it's an and, which is why we have the ampersand here. And the first one says, hey, popularity is exactly equal to 5, but price is less than $3.50. We can quickly grab those rows, and we see that there are 7 items where indeed all of these items have a popularity of 5, and they all have a new price that is less than $3.50. Next question asks, what are all the items that are dairy, produce, or meat? And so this is asking multiple or statements, so multiple conditions. Department is equal to dairy, or department is equal to produce, or department is equal to, oh, I have produce twice here, so we want to go ahead and fix that. And turn that into meat. There we go. And we have an or sign in between each of those 3 conditions. We go ahead and run that. And we can see all the rows that are either produce, dairy, or meat. That's kind of a pain to keep typing or over and over again, right? So I told you up above about the %in operator. And what that does is it's a shortcut that says, hey, you have a vector here, department, and you want to look for if any of those values match any other vectors of values. And you might be tempted to say, hey, let's just use an equal sign, right? And we want to look for anything that's dairy, produce, or meat, right? You might be tempted to just use an equals equals. That doesn't actually give us what we want. And you'll see in a moment why. We actually have 18 values that match that are in dairy, produce, or meat. But when I used equals equals here, it gave me just 8 rows. And the reason is equals equals says, hey, I want to compare this to just one thing. And it's really good at comparing to just one thing. But the % is for comparing to multiple things. So you can take the code up here where we did multiple ors, and you can reduce it down to this code right here and say, okay, find anywhere where department matches any of these values. Again, to do that, where we want to match it to a vector, we use %in %. In fact, you could always safely, for the most part, use %in %, even if it's with a single value. Now, granted, you could use equals equals here, and you get the same results. But if you want to always be safe and clear, you can use %in %. Now, there might be some speed or optimization trade-offs you're making by doing that, but if you at first you're hey, I don't know what to use, if you use that %in %, that's a pretty safe bet. You can also negate this. So you can say, okay, I want all the times where where all the departments aren't dairy, produce, or meat. And to negate that, we're going to use the negation sign. Okay, and I'm going to explain a little bit about what this %in % does. Let's come up here to the console, and we'll say, give me the values 1 through 3, right? And we want to compare that against the value, another vector, and we'll say all the 4 through 8, right? We want to know all the places in 1 through 3 that match 4 through 8, the vector of 4 through 8. And we should get a return value. See if you can think about what it should return. Returns a logical vector. And the reason they're all false is 1 through 3 never matches 4 through 8. So let's actually bring that down a little bit to 3. Now what will happen? this 3 here matches a value here. Okay, and you'll see what's returning. It returns 3 values here because that's what the first vector has. So for instance, if we up that first vector up to 1 through 4, we now have 4 values, and it returns 4. And we have the last 2, 3 and 4, that is, the last 2 values, do match some of the elements here. Okay, so it returns a logical vector. And by putting a negation sign in front of it, we actually flip it, and we can say the first 2 elements are true and the last 2 are false. And why would you want to do that? Well, come down here, let's come down to the code, and let's say we wanted all the departments that are not dairy, produce, or meat. Well, we just simply throw a negation sign in front of it, and now it's giving us all the departments, beverage, bread, canned, and so on and so forth, that aren't dairy, produce, or meat. Okay? Interesting little tidbit, you can also filter on strings, and you can say, I'm going to show this. I've never actually used it, but it's interesting nonetheless. Give me all the items that have a starting letter greater than R, or I guess in this case equal to. Interesting, but I have not myself actually used it. Okay, we're now going to move into the arrange verb. We've finished up working with select and filter, and we're now moving into arrange. Now, arrange sorts a table by a column or columns. Okay, and you start off with the data, pipe it to arrange, just like we have with all the other verbs. And then you give it a column or column names. Here I have descending. I'm actually going to delete that. And the question is, what are the most popular to least popular? So we're going to arrange by popularity. And we can see, hey, all these start off with 1s. That's not what we really wanted. We wanted the most popular. So we put a descending around that with the DESC command. And now it's arranged the table on down by popularity. So that can be quite useful. Here's the next command, arrange by the most expensive items, or the cheapest to the most expensive. In this case, we do want ascending, not descending. So here's the cheapest, moving all the way up to the most expensive. In this case, it's only showing the first 10 rows. If we showed more rows, we could see the most expensive. And here we do it descending. We flip it around, and we can see the most expensive product is skim milk, then followed by pineapple. Next question asks, what are the cheapest to most expensive items in each department? So a really nice feature of arrange is you can actually do it on multiple columns. So first we'll arrange by department, and then we'll arrange ascending on new price. And here we can see that it starts with the beverage department, and it's listed from new price. $2.99 is beer, clear up to soda pop, which is $3.31 per unit price. Okay, we could do that descending as well. We can see it starts with beverage, starts with the most expensive, soda pop, clear down to beer here at $2.99. And we could have also sorted descending by department. So if it's not a factor, which in this case it's character, department is character, it will just do it alphabetically. So it starts with B because that's alphabetically comes first. So let's go ahead and sort descending on that. And we wind up with produce coming first now because we sorted descending, and lettuce is the most expensive in that department, clear down to apples, which is $2.39. That's really quite nice. Next question asks us to arrange by when the item was last shipped, and that's in descending order. And you can see that we're descending or ordering or arranging on date. And the last item to ship was water. If we want to know the oldest item, in this case, we'll do an ascending order, and rolls have went out longest ago. That is, whereas water went out on the 28th, rolls went out on the 10th. So I would encourage you right now to pause the video, explore with the arrange verb a bit here, and do a couple of your own queries. So mutate is a really powerful tool, and what it does is it takes values or columns, or I should say rows, and it makes exactly that many more rows as a new column. So it can take old columns and make new columns out of them, right? I think it's a bit easier to understand this by actually coding up some. So it says, and usually we use these mutate with a window function. We don't have to. So we might, for instance, we'll get into this, but you might group by a particular grouping variable, and you might want to find the mean for that grouping variable, and you might want to make a new column that adds that mean per group, and that would be a summary function used within a mutate statement. But typically within a mutate, we want to use a window function. So we want to take one-to-one, operate on one value, do some sort of transformation to it, and return a new value, one-to-one. So if we pass 7 values, we get 7 new ones. So the first question asks, what is the unit price on each item? And a unit price takes price divided by weight. And in this case, I'm going to apply a round to it. I think it might actually be better to kind of back out here and explain a little bit about Mutate. So you start with a data set, pass it into Mutate. First thing you want to do is give it a name, otherwise it'll give it some sort of name that you may or may not like. We'll call it unit price equals weight, or I'm sorry, new price divided by weight. And we can see it created, well, I guess we can't see that at all. Let's get a little more real estate here. We can see it created a new column here where it gives us the unit price. And it allows you to compare groceries, one item to another, and see if you're getting a better deal, because they might have different weights and different prices. Okay. Next question asks, and you can see, by the way, that we operated on two different columns. You could operate on just one column. Perhaps you might want to just subtract a constant from that. And we might do price M2 for -2. You can see all it did was take the new price minus 2 from it, $2. Okay. We could also do something like square root. And here we probably should name it a little bit better than that. Price square root. So we took the price and just took the square root of it. Okay. Let's move on to next question, and this is used quite a bit in business. So you want to know price difference, right? So it's asking us the price difference between the new price and the old price. So we want to know how much the price has gone up. So we take, this is a change, and that's why we name it change equals new price minus old price. And we'll take those columns and column-wise or row-wise do the subtraction for us. And we can see it gave us a change. So from old price to new price, it went down 3 cents. Here we see for soda pop, the old price was $3.25, and it went up to $3.31. So we have an increase in 6 cents. Now, oftentimes we want to know percent changes. And here we name it per change. And let's kind of read it like this. We first want to calculate the change, and then we'll divide it by the old price. Notice that I wrap it here in parentheses, and that just makes sure that the order of operation happens the way we want it to happen. And that 1 is kind of floating around there. I'm going to get rid of it. And let's actually get rid of the 100 first and see what it does. It gives us the proportion change, as we would expect. And if we want the percent change, we just do 100 times. And now we get, oh, it's about a negative 1% decrease, or we could just say a 1% decrease from the old price to the new price. Here we can see a larger, it's almost a 2% increase. We can see here it's about a 2.5% decrease for 1% milk. Okay. Next question asks, what's the revenue made per product? And that's just the difference in what people are paying for versus what the store paid. So that's new price minus wholesale. Okay. Now note that you can actually include more than one column, newly created column per Mutate. So I'm going to give us a little bit more real estate here. May actually have to go a little bit bigger. And what we do is we took the change from up above, right here. All I did was just bring it down here. Put a comma after it to separate the columns I'm making. And then to do prop change, we do change divided by wholesale. Okay. And then we can see a percent change, or a proportion change, right? Now, perhaps I didn't do a good job explaining this. I guess I had just said that we took what was up above here. That was not what the question was asking. It was a little bit ambiguous here. I guess it wasn't really in question. It was just taking right here the change or the difference between what the customer pays for the product minus what we paid. So we have here that change, and we want to know the proportion of what we paid, how much we make in revenue. So it didn't quite match up to what we had up above here. But if we wanted to, we could bring it down here and do that and divide it by old price. And that'll give us the prop change. And we could even add more columns. This probably won't show up because I probably have too many columns, so we might need view to view it. We can do then per change equals prop change times 100. Yeah, we ran out of real estate here, so I'm going to go ahead and just wrap one more chain on there. It's called chaining when we use the pipe with a view. We can view it. We can see that last column. You can see that it multiplied the prior column by 100. Okay? So that's a really powerful aspect of mutate, is you can actually mutate several columns at once. They might even be unrelated columns. So for instance, we could take weight, and we could do weight 2 equals weight divided by 10. I don't know why that's useful. We could do that. And we can see that we create another unrelated column. And you can create as many as you want. You can even notice that I used change here down below. So long as you've already created it up above, you can use it down below. So a really powerful aspect of mutate is creating several columns at once. Now the real power of dplyr is that you can combine several of these verbs together. And I know we haven't got to summarize yet or group by, but we've so far learned 4 of those verbs. And we've already got quite a bit of power that we can be using. And we see here it's asking us to select department, item, wholesale, and new price. So we did that here in the first step. Show you what that returns. Then it says, what are the items that are marked up at least 25%, arranged from largest to smallest percent markup? So a markup is the difference in what people paid versus what the store paid. And we want to see, we want to create a new variable. We're going to call percent change, or we could call it percent markup, whatever you want to call it. We run that, and we now have percent change right here. And we want to find all the ones that have, well, I suppose we can sort that, because that's what it asks us to do, to arrange it descending. We see the largest markup is 27% markup. Might be interesting to see it by smallest too for just a second here. We have some that are as low as 22% markup. And the last thing it asks us to do are just grab the ones that are at least 25%. Went ahead and did that, and there are 12 of them. Now note that we could have actually flipped this arrange and filter around. It's a nice thing about a grammar like this is it doesn't tell you exactly the order you need to do it in. You can use logic to figure that out, and it will actually return the same exact data set. It didn't matter when we, in this particular instance, when we filtered and when we arranged. Now we'll be moving on to bucketing. Bucketing is useful when you have some sort of numeric vector and you want to cut it or bucket it up into categories, right? So for instance, you might have price and you want to bucket it into high, medium, and low price, right? And to do that, in R, we use the cut function. You can see the source code for it just by typing code or cut into the console. Because it's a base function, we are unable to see, because it has methods attached to it, we're unable to see the source code. There are ways to do that, but it's beyond the scope of this class. If we want to see more about the cut function in the help for it, we type !cut. And I've stretched my console window over here, so we're not seeing that at the moment. Let's go ahead and get a little more real estate. You can see that it opens up a help file and tells us about cut. I'm going to talk to you about this powerful function, and I'm going to talk by showing you the code. So the first argument to cut is a vector that you want to cut up, right? And here we're doing 1 through 10. And the next value are breaks. And you can pass one of two things. You can either pass to it the number of breaks, which is a single value, or you can pass to it cut points. And if you pass a single value, it'll cut it into equal buckets, or it'll do it as equal as possible. And I'll show you what that looks like. We can see that it cut 1 through 10 up. There's 4 values here, 3 values, and then 8, 9, and 10 got into the last bucket. So again, 1, 2, 3, 4 are in the first bucket. 5, 6, and 7 are in the second bucket, and then 8, 9, and 10 are in the last bucket. And you can see because it says levels, this is actually a factor. This can be pretty useful, and we'll talk more about factors in the future. Another powerful aspect of cutting is to actually pass in cut points. And you might think that, hey, I have 1 through 10, and let's say I wanted to cut it at 2 and 6, right? These are the 2 places I want to cut it. What happened? And you can see there's some missing values here. And let's go back to our slides for a second and talk about why. So typically, when you think about cut points, you can think of it kind of like rope, right? Let's say we want to cut it at 2 places, like 5 and 9. You think of cut points typically as, oh, I have 2 places I want to cut, and I'm going to get 3 buckets, right? I want to cut it 5 and 9, right? But R is a little bit different. R expects you to go ahead, if you want cut points, it asks you to, hey, give me the lower limits and the upper limits as well. So in this case, we say that the lower limit is 0. You could actually go anything below 0. You could do up to negative infinity. And you can say the upper cut point is 11. Anything 11 is the max I expect. And you could do anything above 11, clear up to a positive infinity. So, those upper and lower bounds depend on what you think possibly the limits are. Okay? Let's go back to coding a bit here. So, if I want to cut 1 through 10 at 2 and 6, I have to give it a lower bound and an upper bound. Let's go ahead and do that. And there, that makes sense now. We have 1, 2, 3, 4, 5, and 6. And you can see 6 was included in this cut. And there are ways that we can say, 6 should actually be included on the other side, and we'll talk about that in a moment. And then 7, 8, 9, 10. Oops, I apologize. I forgot 2 was our first cut point, not 6. So we have 1, 2, and we can see that 2 was included in that cut. And the next cut is 3, 4, 5, 6. 6 was indeed included in that cut, and then 7, 8, 9, 10, right? And that's pretty useful. The next thing I want to talk about is, typically though, this is kind of hard to read. Now, if you're a mathematician, this is probably a bit easier to read. The square brace tells you that indeed this interval will include that value. The round tells you anything above that value. But it's kind of difficult to read. So you can actually pass in labels for the number of buckets. So there are 3 buckets here. We can actually relabel this. And to do that, you pass the labels argument into cut. And here we have 3 buckets, so I've passed low, medium, and high. Let's see what that looks like. And that's a bit more human-friendly to read. Now, I told you that up above here, 6 was included in this interval, right? There is a way to say, actually, flip it the other way around. Put this as round, parenthesis, and put the lower bounds as the square parentheses. So the lower bound will include that value. And I think it's easier to understand by actually running code here. And the way we do that is we say, instead of right equals true, which is the default, we'll say right equals false. And we can see now, 0 through 2. 2 was not actually included in the first interval. 2 is included in the second interval. So this is 1, 2, 3, 4, 5. And 6 was not included in that first interval. It's included in the second one. 6, 7, 8, 9, 10. And I put it all together as a data frame because it's kind of easier to look at it all together. And the first one is setting 3 equal buckets. We can see what happens there in the first column here. Second one, I just gave it cut points. We can see what happens. Here we gave it labeled cut points. On the last one, we included the upper value that was previously the upper value is now in the lower value in the next interval up, and you can see what happens. And I think it's important to realize what cut is capable of. Maybe you won't wrap your head around everything, but you realize what cut is capable of. You might not remember the arguments and such, but you know what it's capable of. You can use question mark cut and help you to learn how to bucket numeric variables up into categories. So let's get an example of when this might be useful. Let's say that prices, we want to bucket them into high, medium, and low prices, right? So we chose, and I'm choosing this arbitrarily, but you probably have something to inform this, that anything from $0 up to $2.50, that's a low price, right? And then anything above that, up to $3.25, that's a medium price. Anything above that is a high price, right? And then I have, so you can see, we use Wegmans mutate. So you put a cut inside of a mutate is really quite powerful. We're going to name it price bucket equals, and now I have the cut function here. And I broke it onto several lines here. The first value is X. That's the price, new price. Second is the breaks. I gave it cut points, and this is the upper and lower bound, and the 2 places in the middle that I want to cut. And then we gave it labels. So the number of labels is equal to the number of breaks minus 2, because you don't need labels for the upper and lower values. And let's see what that looks like. I'm going to go ahead and get a little bit more real estate so we can see what that looks like. A helpful little tip for RStudio, let's say you want to run the last command. You come up to the console, press up, and you see that code comes back, hit enter, and then rerun it. Okay? And now you can see, indeed, the new price has been bucketed over here into high, low, and medium values. This can be really pretty useful in analysis. Last, we're going to move into a concept called regrouping. And this happens a lot of the times where you have categories that they're in different categories, elements that are in different categories, and you want to regroup them together. So some of the data I deal with, we have open text fields or open strings, and users can put in whatever they like. So let's say that sex is something you can put in, and maybe you could type in male, you could type in M, you could type in capital M, A-L-E. All these things really mean the same thing, and we want to regroup them together. So to do that, we can use the case when function. And there's lots of functions that can do this, but this is part of the dplyr, or the tidyverse set of packages, and it's pretty nice. And to wrap our heads around this, I created this string vector here, and I'm going to run that, Control R, and see what that returns. And you can see it's mixed animals. We got like boxer, poodle, Siamese, and such. And let's say I wanted to group this into cats, dogs, and other, right? Or dogs, cats, and other. Case when works like this. You give it a condition, tilde, rename it to this. So if this happens, rename it to this. Okay, so let's see what happens here when we do that. I take X and run just that. And we see, oh, the very first thing was boxer, and it renamed it to this. Everything else didn't meet a condition, so it returned NA, right? And we could then say X equals poodle. If that condition happens, rename it as dog, right? You see, oh, yeah, that's working as we'd expect it to work. Now, this is kind of tedious to keep having to type out X equals boxer, X equals, when we really want them all to be dog, right? So I told you if you're comparing one value and you wind up comparing that same value of X against multiple things, you can use the %in. So we can reduce our code here with %in. And instead of saying well, we could do it as %in boxer, and notice that it gives us exactly the same thing. Or we can combine poodle and boxer into one vector and reduce our code. It's easier to maintain, less likely to make mistakes. And we see, oh, that returned exactly the same thing. And we can go through and see any time or any types of dogs. So for instance, we may say Odie. We see that as well. Starting to capture more. And now we want to capture cats, right? I think we've got all the dogs. I'm just going to cut and paste that exact line because it's almost identical. But instead of renaming things to dog, we'll rename them to cat. And we don't want to find boxers and poodles. We want to find cat things. So Siamese is one. Garfield's another. I'm going to just kind of cut and paste that. Sylvester is another one I see. Let's see what that gives us. Great. Things are doing exactly what we expect. But we still have one NA here, and that's because of fish. And fish doesn't really fit either dog or cat. We actually want that to stay as fish. So what you can do is if you want to retain everything else, the last line you would type is true, tilde. So that what that means is everything else, rename it, and you can give it any value you want. You can say other. That can be useful, right? Or maybe you just want to keep its name. So whatever it already was, retain that name. And if you want to do that, keep its name, you say everything else, rename it what it already was. And here we see, oh, fish was kept. So either of those might be useful depending on this whatever situation you're trying to work through. Okay, so let's actually see this in progress or in an actual process. So we have the Wegmans data set, and we can see here for organic, sometimes no is no, and sometimes it's N. That's really the same thing. So what I've done here is used it inside of a mutate, and that's when the case when is really quite powerful. And we're going to name it organic 2, and then we have case when. And hey, anytime organic is Y, rename it as yes. Every time organic is N, rename it as no. Everything else, keep the name it already was. So you notice that I didn't include yes up above here. I didn't include it here because we want to rename it to yes. So let's go ahead and run that. And we now see, hey, yeah, that no here, the N, has been renamed to no. Now, let's say I wanted to actually use capital yes, capital no. Well, now I still have a mismatch, so I have lowercase no here, uppercase no here. So to fix that, let's use %in. And say if it's Y or if it's yes, go ahead and call it yes. %in, if it's N or no, call it no with a capital. Let's rerun that. I have made some sort of error. I've put a capital yes there. It's a great thing about code. It tells you when you're wrong. And now it's giving what we'd expect. And let's say, we'll keep it there. Now, this case when can get even more powerful when you're dealing with strings if you learn some regular expressions. That's beyond the scope of this class, but it can be quite powerful. I think it would be useful now to practice some of these techniques we've learned. We learned how to use select, filter, arrange, and mutate. We also learned how to bucket things up using the cut function. We also learned how to regroup things using the case when function. And I think it would be rather useful to practice that a bit, and then also practice combining these together.